September 1943, a Gestapo checkpoint on the Belgian-French border. An elderly businessman shuffles forward, dragging a battered leather suitcase. The officer waves him through without opening it. 3 hours later, London receives a transmission from inside occupied France. The signal originates from that same suitcase. The elderly man never existed. The suitcase had just transmitted coordinates for a weapons drop that would arm 200 resistance fighters. Welcome to the story of the Type B Mark II suitcase radio, the most sophisticated covert communications device of the Second World War. Between 1941 and 1945, SOE, the Special Operations Executive, deployed approximately 400 of these devices across occupied Europe. Each one looked precisely like an ordinary traveler's case. Each one contained a complete radio transmission and reception system. Each one could send a message to London from anywhere in Europe. But the technical challenge of building such a device pushed British radio engineering to its absolute limits.
The problem facing SOE in 1940 was brutally simple. Agents needed to communicate with London. Standard military radios weighed 30 kilograms. They required external power sources. They needed lengthy aerial wires. They screamed spy equipment to anyone who saw them. German direction-finding teams could locate a transmission within 20 minutes. The average life expectancy of an SOE radio operator in occupied France was 6 weeks. SOE turned to John Brown, a signals engineer who had worked on commercial broadcast equipment before the war. Brown's workshop occupied a corner of Station 9, the secret SOE development facility at Welwyn in Hertfordshire. His brief was impossible. Build a radio that fitted inside a standard suitcase, make it powerful enough to reach England from anywhere in occupied Europe, ensure it could operate on local mains voltage or batteries, make certain it looked completely innocent if opened by a casual observer, and deliver 300 units within 12 months.
Brown's solution came from an unexpected source. Commercial traveling salesmen of the 1930s often carried sample cases fitted with display compartments. Some had false bottoms for hiding competitor products during demonstrations. Brown realized that a suitcase with multiple compartments could conceal radio components whilst still appearing functional as luggage. But the engineering challenges were extraordinary. The Type B Mark II measured 45 centimeters by 30 centimeters by 15 centimeters, standard dimensions for a medium business case. The outer shell used reinforced cardboard covered in leather or canvas, identical to civilian luggage. Inside, Brown created a masterpiece of deception. The top half contained actual clothing, toiletries, or business papers. Each case was customized to match the agent's cover identity. A traveling salesman's case held product samples. A businessman's case contained contracts and correspondence. Even the wear patterns on the items matched the supposed owner's background. The radio components occupied the bottom half, concealed beneath a false base covered in the same lining material as the case interior. To access them, an agent pressed 2 hidden catches disguised as corner reinforcements. The false base swung down on concealed hinges. The radio itself consisted of separate modules: a transmitter unit, a receiver unit, a power supply, removable crystals for frequency selection. All components used miniaturized valves, some of the first applications of this technology in field equipment. But the true genius lay in the antenna system. Standard radio transmitters required lengthy aerial wires. Brown embedded the aerial into the metal frame of the suitcase itself. The hinges, corner protectors, and carry handle formed a continuous electrical path. When closed, the case functioned as a perfectly innocent piece of luggage. When opened at the correct angle, approximately 120 degrees, the frame formed a functional aerial. The effectiveness was remarkable. A Type B Mark II could establish contact with Station 53A, the SOE receiving station in Oxfordshire, from as far away as northern Italy.
Power options demonstrated equal ingenuity. The case could operate from mains electricity, using a power supply that fitted into a separate compartment. For locations without reliable electrical supply, it accepted standard wireless batteries. These were available commercially throughout Europe, arousing no suspicion if discovered. The transmitter produced 15 watts of output power, sufficient for ranges exceeding 1,500 kilometers under good atmospheric conditions. The receiver covered frequencies from 3 to 16 megahertz, the standard range for military and clandestine communications. Operating procedure required careful attention to security. An agent never transmitted from the same location twice, never transmitted at the same time, never transmitted for longer than 15 minutes. German radio direction finding teams used triangulation. 3 listening posts could pinpoint a transmission source within a 5-kilometer radius. Mobile detection vehicles patrolled major cities. These vans contained sophisticated receivers and rotating directional aerials. Once they detected a transmission, they could locate it to within 200 meters in under 10 minutes.
If you're finding this deep dive into British wartime technology interesting, subscribing helps the channel and ensures you don't miss the next one. The first combat deployment occurred in May 1941. An agent codenamed Mark parachuted into occupied France carrying case number 007. His mission targeted a synthetic rubber factory near Lyon. On the 3rd night after landing, Mark established contact with London from a farmhouse 30 kilometers from his drop zone. The transmission lasted 11 minutes. He reported successful arrival, provided intelligence on local German troop movements, and requested a weapons drop. Station 53A received every word clearly. Mark continued operating for 14 months before German forces captured him. His suitcase vanished into Gestapo headquarters. Whether they understood its true nature remains unknown. Production accelerated through 1942. The manufacturing facility at Station 9 could produce approximately 30 cases per month. Each required 40 hours of skilled labor to assemble.
The components came from multiple sources: valve manufacturers in London, transformer specialists in Birmingham, the cases themselves from a luggage factory in Manchester. Nothing could indicate military purpose. Nothing could reveal the final product. Security meant every component appeared to serve civilian purposes. Training SOE radio operators took 12 weeks. Students learned Morse code until they could transmit and receive at 25 words per minute. They studied radio theory, power supply calculations, fault diagnosis. They practiced disguising their transmissions in the distinctive patterns called fist, each operator's unique sending rhythm. German interceptors learned to recognize individual operators by their fist. If a new operator used a captured agent's radio and call signs but transmitted with a different fist, London knew immediately the original operator was compromised. The Germans developed their own version. The Torn.F.Bay1 suitcase radio appeared in 1943. German agents operating in Britain used them. But the German design revealed fundamental differences in approach.
It was larger, heavier, more powerful, less sophisticated in its concealment. German engineers prioritized performance over disguise. British engineers understood that in occupied territory, disguise saved lives. American OSS also developed suitcase radios. The SSTR-1 entered service in 1944. American engineering favored different solutions: more standardized components, greater reliability, less customization. The SSTR-1 could be operated by personnel with minimal training. The British Type B Mark II required skilled specialists. Both approaches had merit. American radios equipped resistance movements. British radios supported deep cover agents. The Type B Mark II influenced more than just communications. It affected how SOE planned operations. Agents could now report immediately after landing. They could receive updated instructions based on changing battlefield conditions. They could coordinate with local resistance movements in real time. Before suitcase radios, an agent might wait weeks for a courier to carry messages to a neutral country. Intelligence became perishable. Hours mattered.
The suitcase radio transformed intelligence gathering from a historical record into a tactical weapon. One particular case achieved legendary status. Case number 142 belonged to an agent named Noor Inayat Khan, codename Madeline, a wireless operator working in Paris during 1943. After the Gestapo arrested her entire network, Khan continued transmitting alone for 4 months. She changed locations constantly, transmitted at irregular times, avoided patterns. German direction finding teams came close repeatedly. They never caught her on the air. Eventually, betrayal led to her capture. Her suitcase radio transmitted its final message in October 1943. Khan died in Dachau concentration camp in September 1944. Her case survived. It resides today in the Imperial War Museum. Production figures reveal the scale of the operation. Between 1941 and 1945, Station 9 produced between 400 and 450 Type B Mark II radios. Each cost approximately £200 to manufacture,
equivalent to £8,000 in modern currency. SOE deployed them across France, Belgium, Netherlands, Denmark, Norway, Poland, Czechoslovakia, Italy, and Greece. Approximately 120 were captured by German forces. 73 operators died in captivity. 206 survived the war. Post-war analysis showed the Type B Mark II achieved remarkable success rates. Operators established contact with London on 93% of attempted transmissions. The average operational lifespan of a radio was 8 months. The longest-serving example remained in use for 27 months. German forces captured intact radios, but struggled to exploit them. The frequency crystals could be changed in seconds. If an operator suspected compromise, new crystals transformed the radio into a device the Germans could not monitor without knowing the new frequency. The technology influenced Cold War developments. Soviet intelligence studied captured examples extensively. KGB suitcase radios of the 1950s borrowed heavily from the British design.
American CIA equipment incorporated similar concealment techniques. The principle of hiding sophisticated electronics inside innocent objects became standard tradecraft. Modern intelligence services still use versions of the same concept: laptop computers, mobile phones, everyday items concealing communications equipment. Today, surviving examples command significant attention from collectors. Approximately 35 complete Type B Mark II radios remain in existence. Most reside in museum collections. The Imperial War Museum holds 6 examples. The Churchill War Rooms display 2. Private collectors occasionally acquire examples at auction. In 2019, a fully functional case sold for £47,000. In 2022, a non-working example with documented operational history reached £32,000. The technical specifications now seem primitive: valve-based circuitry, manual frequency selection, Morse code transmission. Yet within the context of 1940s technology, the Type B Mark II represented the absolute cutting edge of portable communications. It compressed equipment that normally filled a room into a device one person could carry.
It disguised military technology as civilian luggage. It kept agents alive. John Brown never received public recognition during his lifetime. He died in 1953. His work remained classified until 1972. Station 9X continued operating until 1946, then vanished from official records. The workshops became commercial premises. The equipment was destroyed or scattered to classified storage. For decades, the story of the suitcase radio existed only in classified files and the memories of surviving operators. The Type B Mark II succeeded because it solved a problem others thought impossible. It gave SOE agents the ability to communicate from deep inside enemy territory. It turned occupied Europe into a two-way battlefield. It allowed London to direct operations in real time, and it looked exactly like what every traveler carried: an innocent suitcase, nothing more. That deception terrified the Gestapo more than any weapon, because they never knew which traveler carried it.